Hello, everyone. I want to welcome you to another section, and in this video, I'll be talking about diffusion. It is a very important topic in both physics and chemistry. So, to start with, what is diffusion? Diffusion simply is the movement of molecules or ions from regions of higher concentration to a region of lower concentration. Simply put, it can also be referred to as movement of molecule through concentration gradients. Now, an example of diffusion can be seen in some of things that we do in real life. For example, when you are cooking your noodles, water diffuses in the noodles to make it big and soft. That process is also an example of diffusion. Another example of it is seen when you add a drop of colored substance, probably dye, when you add it to a volume of water. Within a short time, you realize that the color of the whole volume of water changed to the color of the dye. That process also is typical of diffusion process. But in this video, I'll be talking about the rate at which diffusion occurs. The rate at which diffusion occurs relates to the relative molecular mass of molecules that are involved in diffusion. And that relationship is described by Graham law of diffusion. Graham law of diffusion states that the rate at which molecules diffuse is inversely proportional to the square root of the relative molecular mass of the molecule. That is how, which is the rate of diffusion, is inversely proportional to the square root of relative molecular mass. And this implies that as relative molecular mass increases, the rate of diffusion tends to decrease. And we can also infer that large molecule will tend to diffuse slower to compared to um, very small molecules. At the same time, from this expression, if I input proportionality constant, then I will have that R will be equals to K over square root of M, where K, like I said, is the proportionality constant. If I make the K something of formula, then I will have that K equals to R, and I have square root of multiplied by square root of M. From this expression, that is, if the multiplication of rate of diffusion and the square root of relative molecular mass gives us a constant, that implies that if I'm looking at two different molecules, I could say that R1 and square root of M1 equals to R2, and I have square root of M2, which I can also rewrite to be R1 over R2 equals to square root of M2 over M1. So, and this expression is a very important expression that we will need when doing calculations involving diffusions of two molecules, molecule 1 and molecule 2. But because the rate of diffusion can also be written in terms of volume and time, that is, rate of diffusion can be equals to change in volume over change in time. So therefore, in some cases, we can always relate volume and time to the relative molecular mass. Or yes, like I said, we can relate volume and time to relative molecular mass. But depending on the way or the situation described in the diffusion process, sometimes two molecules can diffuse within the same time, but with different volume. At the same time, sometimes two molecules can be the same under different time. So we can have those two, that is, we can have volume to be constant in some cases, we can have time to be constant. So in the first case, let's take the first case that when time is constant, then we can have that V1 over V2 equals to square root of M2 over M1. That is, let me call this the second expression, this is the first expression. That this is when time of diffusion is constant or is the same for the two molecules. But in case when volume is constant, then we have this expression whereby we have T2 over T1 equals to square root of M2 over M1. And that's the third expression, which is when volume is constant. So take note of the difference between the two. This expression is V1 over V2 equals to square root of M2 over M1, while this one is T2 over T1 equals to square root of M2 over M1. And like I said, depending on the kind of situation described in the question, determines which of these three expressions, expression 1, 2, and 3, you are going to use. So if the question describes the situation of division of two molecules to occur within the same time, then you can have this. That is, if they occur within the same time but different volume, then you can use this expression. If they give us that the division of two molecules occur under different times but the same volume, then you can use this expression. But if they do not talk about either the volume or the time, but they only give you the rate of at which division occur, then you can use the first expression I've given to us in this case. So depending on what is stated in the question determines which of the expressions that are derived from the ground law of division that you are going to use. Now, let's look at an example on calculations involving division. In the example that I've written there, the question says, what is the rate of division of a gas that has mass twice another gas that has a rate of division of 4.2 mole per minute? So from the example, or let me say from the question, the first thing to take note is that we have two gas. We have two gases, so we can say let's say we have gas A and gas B. So we have now in the question also, so the first thing I'm doing is to denote the two gas with variable A and variable B. In some cases, you can also use 1 and 2, gas 1, gas 2, but you can pick any variable of your choice to represent the two gases. Now, from the question, we know the rate of division of one of the gas, while we do not know the rate of division of the second gas. So let's assume that the gas that we know its rate is A, and the one that we do not know its rate is B. Therefore, I should say that R A is 4.2 and a half mole per minute, while RB is unknown. Now, another thing also to take note from the question is that they said the mass of the gas that we do not know its rate of division is twice the mass of the gas that we know its rate of division, which implies that MB will be equals to 2MA. That is, MB, the mass of gas that we do not know its rate of division, equals to 2MA, which is the mass of gas that we know its division rate. So from these things that we have bring out of the given question, then we can now apply our expressions. But from what is given to us in the question is which one of the expressions are we going to use. Now in the question we have the rate of A, we have the rate of B, we have the mass of A, and we have the mass of B. That implies that we use the first expression, which is RA over RB equals to square root of MB over MA. So the next thing for me to do is just to insert all of the things that I'm giving in the question into this expression. So our RA is 4.2, so that means that we are going to have 4.2 over RB, which is the rate of gas that we do not know, equals to square root of. Now, from this expression that we give ourselves, we have already said that mass of B is 2 times mass of A. So that means that we change this MB to 2MA over MA. Then from this MA we cancel MA, and then we're going to have that 4.2, we have RB will be equals to square root of 2. And that implies that RB will be equals to 4.2 over root 2. Therefore, RB equals to 2.97, we have mole per minute. And that will be the rate of diffusion of the gas, of the other gas, which we do not initially know its rate of diffusion. So this is an example of a question that involves diffusion, and I've shown us how we can go about the process. So the first thing is try to note what is the conditions given in the question and try to bring out everything that is given to us in the question, probably in terms of rates of the two gas involved, the mass of the two gas involved, and then you can now use the correct expressions in order to solve the given problem. So in this case now, the rate of division of the gas, which has a mass twice another gas that have a rate of division of 4.2 mole per minute, is 2.97 mole per minute. And this is where I'm going to stop. And in the subsequent video, I'll be working more examples on division so that we can have more understanding. At the same time, in subsequent video, I'll be talking about osmosis. So I would want to thank you for watching, and I would like that you do well to share with friends that can also be in need of this lesson, and do well also to subscribe. Thank you.